I'm Bryant, tutoring high school chemistry. Today's topic is stoichiometry. Stoichiometry is one of the core concepts of chemistry. It's also extremely easy. What it is basically dimensional analysis. We covered dimensional analysis in another lesson, so if you need to refresh, right over there. So, let's go on and do some of this stuff. But first, we need to talk about the mole. The mole is important in chemical equations and hence stoichiometry. What the mole is aside from a cute furry creature that lives underground, 6.022 times 10 to the 23rd power of anything. You could have 6.022 times 10 to the 23rd eggs, which is far too much. But yes, generally this is used with atoms. You see, 1 mole of anything is that thing's atomic mass. Like, okay, say you've got an atom of carbon. We know that that weighs 12 AMU simply by going to the periodic table. It's the number on the bottom of the box. Well, if we had 1 mole of carbon, that would weigh 12, not AMU, but grams. Very simply, if you can find something in AMU, a mole of that something will be in grams. So let's do some real stoichiometry now. We have the chemical equation 2HBr plus zinc goes to zinc, Br2, and H2. Conveniently balanced for us. Woohoo! Okay. So now some stoichiometry. If you have 5 moles of HBr, then how many moles of hydrogen do you produce? Well, we set this up like dimensional analysis, starting out with 5 moles of HBr. Okay, so here's where the chemical equation comes into play. See, we know from this chemical equation that if we have 2 moles of HBr, these big numbers all just mean moles, then we will get 1 mole of hydrogen. So that's basically your conversion factor. 2 moles of HBr, it's the same as 1 mole of hydrogen. Great, moles of HBr cancels out, and we're left with moles of hydrogen. 5 over 2, or 2.5 moles. Simple stuff. Let's try another one, though, with the same equation. This one will be a little bit more complex. Let's say you have 647.2 grams of HBr. How many grams of hydrogen is that going to produce? Well, again, like stoichiometry, 647.2 grams of HBr. But now we need to get it into moles, since that's what our chemical equation is in. So what do? Head over to the periodic table. You need to find the formula mass of HBr. Hydrogen, if we check on the periodic table, weighs 1 AMU. Br, bromine, will weigh 79.9 AMU. So if you just add that all up, you get 80.9 AMU. Now, a mole of HBr will weigh 80.9 grams. Great, we can cancel out grams. 80.9 grams of HBr is the same as a mole. So now we're in familiar territory. We just convert moles of HBr to moles of H2. We know that 2 moles of HBr is the same as 1 mole of H2. But lastly, remember, answer in moles. So let's look that up on the table. We know that H is 1 AMU, so 2 H's is 2 AMU. So we know that a mole of H2 will weigh 2 grams. So now we just do our multiplication. Grams of HBr cancels out, moles of HBr cancels out, moles of H2 cancels out, and after a heady bit of calculations with your trusty calculator, we end up with 8 grams of H2. And you're done. To recap, stoichiometry is basically dimensional analysis, except working with a chemical equation. You need to know the mole, 6.022 times 10 to the 23rd of anything, and a mole of anything is its atomic mass in grams. Okay, that's all for now. Again, I'm Bryant. See you next time.